Okay. Ooh, I don't have to shout. All right, so for those of you watching the video, the yay. For those of you watching this on Panopto or YouTube, that wasn't a mistake on your end. There was no audio for the first part of that. We're talking about APIs, and an API is a definition of a set of behavior. That's all I'll recap. If you want the more in-depth what I just talked about, you can find last semester's video and watch that one. You'll get the content. So let's move on. So with MVC, this is taking that idea of an API and having three parts of our program. Thank you. Three parts of our program that will communicate through their APIs. So the MVC, we're going to split this into model, view, and controller, where the model is going to be the logic of the program. This is the guts of the program. This is where all the action happens. This is where all the good stuff happens. The view is only concerned with displaying information, and the controller is concerned with user inputs. So we're going to split our program into these three parts and make sure we keep anything related to those three parts in those three parts. Not going to let them cross lines at all. If they ever have to communicate with each other, they're going to communicate through APIs. The model's going to have an API, and the other two talk to the model via its API, and only its API. It's not going to be concerned with the inner details of the model at all. Visually, it looks like this. The user is going to send inputs into the app through its controller. The controller is going to convert those inputs, those user inputs, keyboard, mouse inputs, whatever, voice recognition. It's going to convert those into method calls of the model's API. So it's going to send those commands to the model using the model's API. And then the view is going to access the model's updated state and represent the current state of the app visually to the user. So this is our GUI. This is taking information from the model and displaying it to the user. The user sees the new information, sends more inputs to the controller, updates the state of the program, sees the new state of the program through the view, sends more inputs to the controller. This is our typical feedback loop for a user. Inputs, visualize the outputs, consume it visually, and then, or auditorily, whatever the program is outputting to the user. And then input more commands, etc. So the model, this is where all the action happens. This is the good stuff. This is most of the code you've written, most of the code you will write for assignments. For the rest of 116, for 220, 250, most of our courses, you're going to be focused on the model. This is where all of the logic of the program happens. Anything that really happens is happening in the model. This is where we like to live. At least for assignments, this is usually the stuff that we're teaching you. Next semester, you're going to learn about data structures and systems programming. Like all that stuff's related to the model. So this is the good stuff. The model is not aware, when using MVC, the model is not aware that the user exists. And this is important for a few reasons. One, it's easier to code if you're not thinking about too many things at once. If you're coding the model and coding like database interactions and stuff, and in the back of your mind, you have to be thinking about the user the entire time. And in your code for the model, you have to be thinking about all that. It's just a lot to manage while you're writing that code. And two, it's easier to test. If we need to test with a user or simulate a user somehow, that's hard. That's really hard to do. So we're going to avoid all that and separate the model into one thing, the core of the app, what we need to actually have the app run, and then expose that to the view and the controller via an API. So we're going to say, here are the methods you can call to interact with this app. Just call these methods whenever something happens. The view is only concerned with output, and it needs to stay that way. It's only concerned with representing the state of the app visually or with sound and stuff. But it can't have any logic, it can't do any processing, or at least shouldn't. According to MVC, if you're following MVC, the view should not do any processing. It shouldn't handle data and change the data, modify it, extract pieces of information. It shouldn't update any state Most importantly, shouldn't update any of the state of the program. The only job of the view is to say, hey, model, what's the current state of the program? Take the state of the program and visualize it for the user. That's it. If it's doing anything more than that, you're not following MVC. The view is output only. The nice part about this is we can swap out the view without changing the model or the controller, potentially. So we can have multiple views for the same program and swap them out. If we want a command line interface for a program, and then later on we want to add a GUI to it, we can do that if we have nice MVC practices, because our model isn't going to change. We're just going to swap out the view and represent the state of the program to the user in a different way. If we want to use a GUI to do that after we've been using a CLI forever, that's perfectly within our coding abilities without changing very much of the app at all. And the controller is concerned with user inputs. So the controller, like we saw on Wednesday with ScalaFX, was anything that's handling events. The events that the user is triggering, the mouse clicks, the keyboard presses, the button presses, all of those events that occur when a user takes a specific action, and we're processing those and then turning them into API calls of the model, that's the controller's job. The controller's job is to be that buffer between the user inputs, the user's actions, and the model. Takes the user's actions, converts them into model API calls, and then calls the model's API. In this way, the model doesn't have to care how the user is inputting those inputs, what kind of devices they're using, anything. It doesn't have to care about any of that. It just cares that, oh, my API method was called. So there are a lot of advantages to this. One kind of, I don't know if I want to say first and foremost, but one really nice advantage is that you can divide work amongst team members. You sit down, you design the project, and you define the API, especially the API of the model. Now, one of you can go and implement that model based on that API. One of you can work on displaying information based on that API. Okay, this is the state, this is the format that we're going to use for all of the information, the state of the program. A team member can take that and start working on the GUI. And then another team member can say, okay, this is how we're going to get user inputs, start the controller code, take user inputs, and then convert them into calls of the API. 3 people can be working concurrently quite easily if you design with MVC up front and have a really nice boundary between each of these three things. Next, it's really easy it's easier to expand, especially if we want to move into new territory. So if we have a web API, where a web API, the view is HTML, CSS, the model is on the server, and the controller is some mix between JavaScript in the browser and some validation code on the server side. That can usually be shared between the client and server. Say we have a web app like this. Oh, it's on a later slide, but I want to say it now. Say we have a web app like this, and we decide that we want to add a mobile app. Well, guess what we're not doing is changing any server-side code. The server-side code is still going to be the same, but we're going to write a new front end. We're going to write the mobile app, which is just going to be the view and the controller. So the view, if it's a mobile app, we're not going to use HTML and CSS anymore. Maybe we use something to convert our web app into a mobile app. There are tools out there to do that. Or maybe we want to be native to that device and start over with the technologies of that device. But we're not rewriting our entire app. We're just rewriting the view and the controller. The controller might change because maybe we want to take advantage of touch inputs instead of mouse and keyboard inputs. So we're going to rewrite the controller, but we're going to convert those touch inputs into calls to the API in the same way that the web-based controller was. So we can have 2 front ends for one app, one server serving apps on multiple platforms. You see this in games. You can have games on multiple platforms. A PC and consoles can play together in the same lobby now. There's just one server with one standardized set of code, but it has an API that's accessed through both of the front ends. And most apps, I guess all social media too. Doesn't matter if you're on mobile, on a PC or whatever, web-based, doesn't matter. And I always like to think of Netflix for this. Whenever Netflix makes a new app for a new platform, it seems like Netflix runs on anything. Most platforms out there, you can run on your Roku or whatever, your phone. It has an app for everything. Each time Netflix develops a new app for a new platform, they're not rewriting all of Netflix. They're using their same model, their same API on their servers, serving the same format, the same data, but they're just writing a new view and controller for that new platform. So just how do you navigate videos and how do you play videos? Those are the two big things that they have to, I'm sure there's a lot more, but those are the two main things that they need to rebuild. Rebuild their interface for the new platform. And you notice you go between devices, the Netflix interface is just a little bit different on each one for whatever reasons. It's because it's a completely different view written from the ground up for that platform. And then it accesses the same model on the back end. So it's one really nice advantage of MVC, right? New view and controller use the same model. So you can use that same model, reuse that code for whatever you want to do in the future. On the jumper example that we saw, the model API were the button presses. Give me a player and tell me if they hit left, right, or jump, and that's it. That's all the model cares about. And then for the controller had to be aware that there are two sets of inputs for two different players. So the model is like, okay, if I get a left arrow press, that's going to be player 1 hitting the left button, and it's going to convert that into an input for left arrow player 1 and call that for the model controller. If A is pressed, then it's going to be, okay, now the player 2 is going to want to move left and send that to the controller. The controller doesn't care that there are two players with two different sets of controls. It only cares that this player hit this button. In fact, the model doesn't even care that there are humans playing this game. We can bot this game. We can write a program that sends commands directly to the model and have that bot have effectively its own controller. The model doesn't care, and it shouldn't care. The model doesn't care what the user is. It just cares that its API methods were called. And the view was the GUI that we saw. The view does a little bit of processing to do the vertical scroll. The view for that, if you look through the code, gets the absolute locations of everything, of all the platforms and the two players, and then it decides which section of that to view, to show to the player. So it does do some processing to affect the scroll, to be able to decide what to show and how to show it, but it's not doing processing that affects the state of the game. The view will never affect the state of the game. And the controller the model separately keeps track of that kill line when a player is too low in relation to the other player. But the view doesn't have any processing that affects the state of the program. In point of sale, so in the homework, you can see quite clearly I have the 3 top-level packages for the project, aside from tests and point of sale. Labeled model view controller, make it 100% clear that I'm using MVC for this project. So the model API, pretty straightforward for this project. It's all of the button presses is the API. So all the button presses, and also 2 extra API methods for the view to control, or to consume. Receipt lines and display string. These are 2 methods that will be called by the view to figure out the current state of the program, to be able to display it to the user. Receipt lines going in the receipt area, and then display string going in the view right above all the buttons. What should be presented to the user? So the view is going to call those 2 methods and display them. And then for our testing, we're going to call these methods and make sure they're returning the right values. So separating this with MVC gives us a way to be able to test our code. We're going to hit the buttons, simulate button presses, and then call these 2 methods and make sure these 2 methods return the appropriate information. So in our testing, we don't have to care that this app is eventually going to be used in a GUI. We just have to care that the model API is returning the correct value after we called its other API methods. So when we're testing, we're only testing the model, and that's where all of your code is going, is in the model. we're testing the model completely independent of the view and controller, as if the view and controller didn't exist. And that's a behavior we really want. We want to be able to test the functionality of our app separate from how the users are going to interact with it. Then we can test the model of the view and controller separately if need be. The controller is going to convert those events, which are all the button presses. It's going to convert those events into calls of the model API. So when you're writing your model API, you're just concerned with, okay, when this method is called, this method enter press is called, what should I do? Now that method is going to be called when enter is actually pressed on the GUI or in your testing, but when you're writing the method, you don't have to care where that input came from, and you don't have to care about things like event handlers and the like, and GUI buttons, Scala effects and Java effects buttons. You don't have to think about any of that stuff when you're writing your model. You think about that when you're writing your GUI, your view, and your controller, not when you're writing your model. Helps us separate our concerns and think about one thing at a time. We get too many things in our head when we're coding, and nothing's going to get done because we're going to be way overwhelmed. We're overwhelmed enough. Coding is hard enough. Using approaches like this and separating things out can help us stay a little focused. And the view is going to be all of our GUI stuff like we talked about on Wednesday. It's going to consume that receipt lines and display string and display it to the user, and along with all the buttons. So with this, your model doesn't care. Your model doesn't care that it's being ran through a Scala FX, Java FX GUI. Why does it highlight in such weird orders? I just want to highlight some lines. It doesn't care that it doesn't care or know about Java FX, Scala FX. One nice benefit, since we can swap out the view and controller, one nice benefit of this is the code that you write for this project can be used in real hardware. It can be used in an actual self-checkout machine. Java runs on billions of devices, as they like to say. Probably runs on, and it runs on most embedded hardware. Get some embedded hardware, get an actual number pad with keys that you can physically press, upload your code onto that embedded hardware, and run your model that you write for this project on an actual self-checkout machine. You might want a few more features just for usability, for user-friendliness, but that code can be run on actual hardware. This isn't some simulation for a course or anything. It's real software that you're writing that can be used on real hardware in a real store to check out real items. And then you make money. This is how we all make money. We're writing real software. Somebody's going to pay you a ton of money when you graduate to write software for them. All right. Any questions at this point? Any questions about MVC? Watch the battery dead. Wouldn't that be a kick? We finally got the mic out of the drawer and it was dead. I wouldn't have been surprised. Yeah, every time you watch a Netflix show, somebody's actually pressing play. Back in my day, they used to mail you the damn DVD. Yes? No, so the question is, do you have to write the API for the project? No, it's already in the repo. Oh, actually, this is where I wanted to jump to the code. Thanks for reminding me. So for point of sale, so this is mostly used in the self-checkout class. This is your API. I already gave you the API. This is mostly to simplify the testing a bit. If the API is already there, you know that in testing, you're only calling these methods. You're going to add more classes, you're going to add more methods, you're going to add more state variables. You're going to add a lot to this class and to this project. But as long as you're testing your self-checkout class through only these methods, then you're guaranteed that I have these methods in my solutions on Autolab, you have these methods defined in your code. The only difference is what those methods do, well, probably not what they do, but how they do, how they implement the functionality that they have. So this is the API, and your goal is to implement these methods to get the functionality defined in the document. if we go, I wanted to go through each of these actually. So view, this is like what we saw on Wednesday. I have a whole bunch of buttons that I'm creating. I created a separate button class just to keep things a little cleaner, to separate that out. Instead of creating a new button every single time, I'm creating a new self-checkout button, which takes the string to be displayed, the action that's going to be taken, the X and Y size of the button, and then the font size, which is 20 right here. So for like, are all the buttons the same size? Oh, all the buttons are the same size in this. I don't need that 1, do I? And then I have all these action classes for the action that should be taken, which we'll jump to in the controller. And then arranging these buttons on that grid to all be displayed where I want them to be. And then the button, the self-checkout display, I'm going to call this update display method, which is going to get receipt lines and display string and display them where they should be. And I'm calling that every time the mouse is clicked. Kind of a little shortcut, so it's updating more often than it has to be, but it's never not updating when it should be. So whenever you click a button, this is going to be called, and we're going to get the new state of the program, get the updated information to be displayed. So that's how we're viewing based on this checkout machine, which is created up here. So I'm creating a new self-checkout machine, calling your prepare store method, and then every time the mouse is clicked, I'm calling receipt lines and display string to get the newest state of the program updated on the display. In the controller doesn't do too much here, but it has one very important job. It's going to define all these action classes which extend the appropriate event handler. They're all action events because these are all buttons. So it extends that, and it's going to say, okay, the clear action, which is going to be attached to the clear button, is going to call the self-checkout model's clear pressed. It's going to call that API method whenever that button is pressed. And we're going to get a reference to your self-checkout model, which is passed in each one of those buttons whenever we're creating a new handler of this in the view class. We're passing a reference to that self-checkout machine that was created to the model. And converting those button presses, these JavaFX, ScalaFX, event handlers, all this stuff, we're separating that into the controller and converting them into API calls of the model. In this way, the model doesn't have to care about JavaFX, ScalaFX. We can swap out the GUI with something completely different. You can write a brand new GUI for this project, and it won't affect anything on Autolab, because Autolab's only looking at your model. That's the only thing I need to test. You don't ever have to change the view or the controller, but you can if you want. If you want to swap those out, this is one of the advantages of MVC. We can swap those out, and the model doesn't have to care about either of those. The model just cares about, here's the API, call this API to interact with the program. And it doesn't care how it's being interacted with. All right, let's talk about databases. I thought, okay, so in 115, if you took 115 here, we introduced you to SQLite, and we had a database that took SQL commands and sent SQL commands to SQLite, and SQLite handled those. I want to compare that to MySQL. MySQL is going to do effectively the same thing, but it's going to happen over a network. MySQL is what we call a database server, which is a separate piece of software that runs on your computer, and then your software is going to interact with it, that other program, through its API. SQLite simulates the same thing by removing all the networking, just using file I/O, and effectively not being a real database. It's not a database server, at least, and it's just simulating a database server using file I/O and being local to that program. We like SQLite because it keeps things really simple in 1.15. I want to say in 1.16 we'll use MySQL, but I removed the requirements to do it, so this is more of a nice to know. But you will, I don't even know if you'll see it. No, it's good to know this stuff for the future at least. I think I cut out all the MySQL from this course. But SQLite is still used out there, notably on mobile apps. When you need a local database to that machine, you're not going to connect to a remote database anyway. SQLite is the right solution there. But MySQL, this is a database. It's going to run separately from your program. So that means if you want to use a MySQL database to test your apps, if you're using a database, you're going to download MySQL, run it, install it on your machine, run it, and it's going to listen for connections by default on port 3306. You're going to connect to it with your code using libraries that are in the pom.xml, and then connect to that database and send it SQL statements and SQL queries and get your information into and out of that database. I'm going to skip over some of this, especially because I'm not having you write any MySQL stuff this semester. Maybe I probably should bring that back now that I think about it. But and some of that's repeat from last time. I thought I had. There's one big point I want to make. I missed the slide that gives me the prompt to talk about it. And now I'm forgetting what it was. I'm sure it was super important. Well, I'm not going to have you just watch me click through it. Anybody have any questions on MVC or how the project is organized? I tried to go faster because we lost a lot of time at the beginning, but I overestimated for that. Yeah? No. So that's, if any lecture is going to have technical difficulties, it's this one, because no, this isn't. So these two lectures, which is why I'm rethinking this. I should change this around. These two lectures don't show up here, but just like Wednesday's lecture, I gave you the code for the project, and it's important to me that you understand, that you're able to understand everything with the project code. I don't want to give you code and just be like, don't worry about that. Don't look at that part of it. I want to explain to you what the structure is. So you're at the point where you can understand every piece of the project handout code and every piece of what you're supposed to be writing for it. But neither GUIs nor MVC show up in the syllabus, so we're not going to ask you about it on the interviews. These two lectures are meant to be a bit of a buffer to give you more time to think about Project 2, to think about point of sale. Point of sale's kind of a beast. You got all the information out there, got a lot of time to process that information and get that thing done. But with that, have a great weekend. I'll see you Monday.